Hi, my name is Jessica Cortez. I worked with Nancy to create our database, which can be used to implement an entertainment store that sells movies, games, books, and music. Project, we decided to create an entertainment store. It's targeted for all types of people, where people can buy books, music, movies, and games. The database displays the customer's information such as the purchase history, personal information like the address, account number, and email, and how much they have spent at our store. Each category will display the ID of the item, the name of the item, the type of genre, rating, and price. For practicality, the owner of the store can use the database to view the customer's account, their purchase history, and preferences to drive sales and promotions. They can add customers and add new inventory to the database. They can also determine items to mark down in price and send emails to customers about promotions and sales. This is our EER diagram. Our main table is the sales table. Our sales table with our purchases table has a one-to-one relationship. Then our customers table to our sales table has a one-to-many relationship, while our music, movies, books, and games have a one-to-many relationship with purchases. So here's our sales table, which is our main table. This table includes a sale ID that has a data type int, the date of the sale, data type date, the total price for the sale, data type is decimal, the customer account number, data type int, the total amount that the customer paid, data type decimal, and the purchase ID and customer ID, which are both integers. In total, the table has 50 rows, but we couldn't include all 50 rows, so we included 17 rows. Here is our purchase table. This table includes purchase ID and the number of items, which are both data type int, the total price of the transaction, which data type is decimal, and the music, movie, book, and game ID, which are all data type integers. There's also 50 rows in this table as well. Here's the customer table. This table includes the customer ID, which is data type int, the first and last name of the customer, the street address, the city, state, and email, which are all characters, data type character, and a zip code, which is data type integer. This table has a total of 30 rows. Here's our game table, which includes the game ID, the name of the game, the rating, genre, and price. Only the price is decimal. Game name, rating, and genre is character, and the game ID is integers. This table has a total of 34 rows. Here is the music table, which includes the music ID, data type integer, the artist's name, the album name, the genre, which are all characters, and the price, which is decimal, data type decimal. The music table has a total of 30 rows. Here's the movie rows, which includes the movie date, integer, the name of the movie, character, the rating, character, and genre and character type, and the price, which is decimal, data type. This movie table has a total of 30 rows. And lastly, the books table, which has the book ID, which is an integer, the book name, the author, the rating, and the genre, which are all data type characters, varchar, and the price, which is decimal. The book table has a total of 30 rows. Here is our first select query, which is a query with an order by clause. So we select all from the sales table and we order by total price. You can see on the total price column, we have the prices in ascending order. Here is the next query that includes a where clause. So we select all from customers table where the state is equal to MI or Michigan. And you can see the result grid, we have three rows that match the select query.
Hi, my name is Nancy Hanna, and I will be presenting. This query deletes a game ID of 34 from the games table. This query updates the price where the music ID is 1. The original price was $14, but then it was changed or updated to $21. This query inserts values into the books table. As you can see, the book's ID of 31 was added into the table along with the values. This query uses an interjoin where the sales and customer tables are joined together to display the sale ID and the last name of the customer. This query uses a left outer join where it shows the 3 columns taken from the customer table and sales table. It shows the first name, the last name of the customer, and the total price. This query uses an aggregate function where it displays the number of sales in December using the count function, the total price using the sum function, and the highest sale using the max function. This query uses a group by and having clause. It shows the customer ID who made 3 purchases where they bought 3 items. This query uses a string function that displays the customer ID in one column and the customer name in another column, separated by a comma. The concat function is used to separate the last name and the first name of the customer, and it is ordered by the customer name and then the ID. This query uses a numeric function. This shows the number of sales using a count function, the total revenue using the sum function, and the smallest sale made by using the minimum function. This query uses a date function. As you see, this column displays the date as year, month, and then day. In the second column, we use the date format where it displays the month, the day, and then the year. This table shows the different formats being used from the sales table. Now to our front end design. This is where the customer will go to buy their items. Coming from the customer view, they will go on this website and they will have multiple options to choose from. They can choose music, books, movies, and games. Let me go back. So you can see each slide. They can their preferred genre. They can have multiple options to choose from, and the ages range from adults to kids. I hope you enjoy our presentation. Thank you.